Hi dear students, so today we have to start a new topic of class 10 physics, that is machine. Okay, so it is the third chapter of class 10 and here we will discuss about the instruments by which we can able to do our work very easily. See, in everyday day-to-day life we have used many such instruments which make our effort less. Means by applying less amount of effort we can able to do much amount of work, and that is machine. How many types of machine we have seen around ourselves? If I am talking the first one, that is known as force multiplier. What is force multiplier? Now force multiplier is a type of machine where we have seen by applying less force. See, applying less force we create or we get more force. Okay, that type of instrument is known as force multiplier. Example, if I am talking about screw jack, which is very commonly known as stepney. In our car, if any wheel there is any problem in a wheel or any problem in the tire, then that tire should be opened. How it can be opened? So in which tire you have to open it, you have to lift that portion, but it is not possible by a person to lift a car, so it is lifted by screw jack. So by applying less amount of effort we can able to lift the car. Okay, so that's why it is known as force multiplier. Your force is multiplied, and that's why you can able to do or you can able to create a force by applying less amount of force. Number 2, changing the application point of force. What is it? Now you are applying a force in one portion, but the force is carried forward to the another portion. Example, we all use cycle. So in cycle, you see there are two type of pinions we have seen. Pinion means some metal wheels having metal teeth. This type of teeth we have seen. Okay. So here we know the paddle is fixed, right? And along with that one chain is connected to the smallest pinion. It is connected like this way. Okay. Whenever we apply force on paddle, we are applying force on the larger pinion, and by the help of the chain, this force is carried forward to the backward smaller pinion, and by that the cycle can able to move in forward direction. Okay, so here I am applying force here and changing the point of application. Applying force here, but the force is actually applied here. Okay, so that is also one kind of machine where we can able to change the direction of force or change the application point of force. Number 3 is a very common thing, changing the direction of force. The direction of force. We want to apply a force in one direction, but we apply effort in another direction. Okay, so what is it? If I am talking about pulling, assume this side the load is there and you are applying force in downward direction. As you are applying force in downward direction, it lifts upward direction, right? So here is an instrument which is a pulley by which you can able to change the direction of the application of force. Okay. Number 4, very important thing, that is known as speed multiplier. It is known as speed multiplier. What is speed multiplier? The speed multiplier is a special kind of instrument by which we can able to do our work very fast. So by see the name only, speed multiplier, that means we are increasing the speed. We are increasing the speed by using machine. If I am talking about scissor, okay. So scissor is a special kind of instrument by which we can able to cut a paper, cut a cloth very fast. So that is a speed multiplier. Okay. So these 4 kinds of machines generally we used. But if it is asked you what is a machine, so machine is an instrument by which we can able to reduce the human effort and make our work very fast, or can do our work very fast. Okay, that is a machine. Now we have to find that whenever we are talking about machine, what important things we have to learn about machine. See, we have already told it is an instrument. As it is an instrument, so what basic things we have to learn about the machine. So first one we are going to learn, it is known as effort. We have used the term several times here. Okay, so effort. What is an effort? Now the force applied on a machine is known as effort. Force applied on a machine is known as effort. Okay, and this is denoted by capital E. Coming to the next thing, load. Force got from machine, it is known as load. Force got from machine, or we can write in another way, the resistive force applied by machine. So simple thing is that what force you have applied on machine, that is effort, and what force you have to overcome, what resistive force you have to overcome by applying effort, that is known as load. Okay, which is denoted by capital L. Now we can able to find one more thing from here, that is mechanical advantage. Mechanical advantage. So mechanical advantage is a property of a machine. If we can able to find it out, we can understand the usability, okay, or the capacity of a machine and how it can be used. If I find out the mechanical advantage, that should be the ratio of load by effort. That means L by E. That is the value of mechanical advantage. So mechanical advantage is the ratio of two forces. One is load and another one is effort. One is load and another one is effort. So as it is a ratio of two forces, so there is no unit, because it is the ratio of two same kind of quantity. This is also force, this is also force. and that's why no unit is there for mechanical advantage. For an instrument, the mechanical advantage can be greater than 1, mechanical advantage can be equal to 1, and mechanical advantage can be less than 1 also. Okay, whatever the machines we have seen around us, for the machines, mechanical advantage can be more than 1, mechanical advantage can be equal to 1, and mechanical advantage can be less than 1. The instrument whose mechanical advantage is greater than 1 should be taken as a force multiplier. Okay, if the mechanical advantage is greater than 1, that instrument or that machine is taken as a force multiplier. What is force multiplier? We have explained. Mechanical advantage is equal to 1, that is used for changing direction or an application of force. Okay. And if I am talking about mechanical advantage less than 1, that is used as speed multiplier. So 4 things we have discussed, or 4 types of machine we have discussed earlier, and by the help of mechanical advantage we can able to give or justify with the help of the number. By see the number or by see the value of mechanical advantage, we can able to understand whether the instrument can be used as a force multiplier or as a speed multiplier, or it is used for changing direction or changing the application point of force. This is mechanical advantage. Now, one more important property of a machine that we have to find out, that is known as velocity ratio. The next important thing we have to find out for a machine, that is velocity ratio. Let's see what is it. Velocity ratio. So by see the name, here we have to find the ratio of 2 velocities. Why there is 2 velocities? Let's see. When we apply effort on a machine, there should be a velocity is created. Assume if I am talking about a pulley. Okay, assume it's a pulley. Here you have to apply effort, here it is the load. So it is load and here you have to apply effort. So as you have applied effort in downward direction, the load will come up. So when you are applying effort, you have given a velocity to this string. Assume the velocity due to effort, that is VE, and due to that the load will comes up, that is also coming with the velocity, that is VL. Okay, and the ratio of velocity due to effort by velocity of load, that ratio, that means VE by VL, that is known as velocity ratio. Velocity due to effort by velocity of load, this is known as velocity ratio. Okay, so as also it is the ratio of two same kind of quantity, so here is also no unit. It is also a number like mechanical advantage. There is also no unit of velocity ratio. Now it can be explained in another way also. Assume if t time is taken for displacement due to effort, displacement due to effort, dE. Okay, what is it? See, when whenever we are applying effort, assume initially the string is here. Whenever you are applying effort, the string is coming downward. So this is a displacement is done by the effort, and that is known as dE. Okay, and in the same time the load is lifted from here to here. Assume the load is coming here. So that displacement we have taken dL. So we have to write here T time is taken for displacement of load, that is dL. Same time is taken. So from here, velocity due to effort, that is dE by T, displacement due to effort by time, and velocity due to load dL by T, displacement of load by time. And now if I take the ratio, that is VR, VR stands for velocity ratio, that we have learned VE by VL. So V equals to dE by T by dL by T. So T will be cancelled out, dE by dL. So we can write displacement due to effort by displacement of load. That is also known as velocity ratio. Okay, dE by dL, dE by dL, and here also you see it is the ratio of two displacements. So as it is a ratio of two displacement, so here also no unit should be there. So velocity ratio and mechanical advantage both should not have any unit. Okay. Now we have to find one more quantity of a machine. See, why we are finding out this? Because we want to find the usability or the capacity of a machine. So by which thing we have to find it? So for that we have to find some properties by which we can able to understand whether the machine is good or not. And for that reason only we are finding out this type of things. Okay. So the next thing, it is very important, that is efficiency. Next thing is efficiency. Now efficiency, it is related with the work done. Till now we are dealing with the forces. Now when we are coming to efficiency, now efficiency tells us the ratio of work done. That means work output by work input, and it is expressed in a form of percentage. Now you might be thinking, so from where this work output and work input has come? What is work output? Work output is basically work done by machine. That means how much work we received, how much work we got from the machine. That is work output. And what is work input? Work input equals to work done on machine. That means how much work you have done on machine. Here how much work we have got from machine and how much work you have done on machine. In another word, we can say that whenever we are talking about work input, so how we have input a work, how we have done a work. So when we are applying effort on our machine, then the work is done by us. When we apply effort on a machine, then some work is done by us. So we can say work done on machine means, that is work done due to effort, and work done by machine means work done due to load. This is the ratio by which we can able to get the efficiency. Assume how much work we have done, that is work input, if we got same amount of work. Okay, how much work we have done, we receive same amount of work. That means if work input is equals to work output, then this ratio, you see, this ratio, that will be 1, because work input equals to work output. Then if I convert it into percentage, efficiency, which is denoted by efficiency, we denote by eta. This is known as eta, just like n, and one part of the n is increased. Efficiency eta equals to 100%. How much work you have done, you have received that much amount of work. But generally it is not possible. Generally it is not possible. Why? Why it is not possible? Because whenever you have done some work, some amount of work is lost due to frictional force and other opposing force. So whenever you have to do work, you have to do work against the frictional force also, against the opposing force also. That work you cannot get back. That means if I want to get work input equals to work output, that means there shouldn't be any friction, there shouldn't be any opposing force, which is impossible, which is practically impossible. It is not possible to get without, to do any work without frictional force or without any opposing force. And that's why we can say if work input and work output, though it is impossible, that type of machine is known as ideal machine. Okay, but what machine we have seen around ourselves, these are known as actual machine. What is actual machine? Where work output is less than work input. Work output is less than work input. That means how much work we have done on the machine, we will not get same amount of work. That means it should always be, if I am coming here, it should always be less than 100%. From here one concept has come. So which machine is known as a perfect machine? Perfect machine is known as such kind of machine whose efficiency is 80% or more than that. 80% or more than that. So 80% means whatever work you have done, 80% of work you have converted as a output, but 20% of work is waste or lost against frictional force and another opposing force. Okay, so this is the idea of efficiency. So efficiency cannot be 100% practically, but ideally whenever we have done numerical, it is possible. And if you have calculated one numerical and if you have seen the efficiency coming more than 100%, then confirm that your numerical is wrong. It is not possible to get efficiency more than 100%. It is also not possible practically to get efficiency 100%. But you have to get the efficiency less than 100. Okay, and for a perfect machine that should be less than 100 but more than 80. And if you have seen it is less than 80 also, it is an actual machine but it is not a perfect one. Okay, now we will go to the next part, that is the relation between efficiency, mechanical advantage and velocity ratio. Relation between efficiency, mechanical advantage and velocity ratio. So relation between mechanical advantage, velocity ratio and efficiency. Okay, what is efficiency? If I am just starting from efficiency, what is it? Efficiency is equals to work output by work input, and we have to just get it in a form of percentage. What is work input? I have already told earlier, work input is equals to work done by effort. Work input equals to work done by effort. So how we can able to find work done by effort? So effort, we know the force we have applied on a machine. Force is effort is how much work we have how much force we have applied on a machine. So that is E, and due to that effort, if it is displaced by dE, I am again doing for pulley because it is easier to explain with the help of pulley. Assume this is your load and you are applying effort here. So as you are applying effort in downward direction, it is displaced by dE. So in the previous class only we have learned that work done is equals to force into displacement. So here force you have applied, it is E, displacement it is dE, so E into dE. Okay, so this is work input. Now coming to work output. What is work output? So work output, that is work done by load. See, this is the load and it is lifted, assume, at a displacement dL. We have done earlier also for the case of velocity ratio, the load is lifted by dL. So it is L into dL, right? Now put the value here, that eta equals to E into dE. Okay, work output, I'm sorry, work output is there. So L into dL by E into dE, and that should be expressed in a form of percentage or into 100, or just give only the percentage sign. Okay, L by E into 1 by dE by dL. By this way we can able to write L by E. What is it? L by E is mechanical advantage. dE by dL, we all know dE by dL is velocity ratio, and that is expressed in a form of percentage. So we can say efficiency eta equals to mechanical advantage by velocity ratio. Eta equals to mechanical advantage by velocity ratio. This is the relation between efficiency, mechanical advantage and velocity ratio. My suggestion is just practice this derivation, because last it has come in 2014, and from then there are the numericals are coming from that equation, but who knows, it can be asked later also. Okay, so practice this, I think it will be good for you. Okay, now we will learn lever. I have already told we will discuss about lever, but before that why we are going to discuss about lever, that we have to see. So in this part, whatever the machines we have to learn, main thing in our syllabus is simple machine. Okay, so what is simple machine? We have already learned it earlier. The simple machine means where there is no electrical connections or any sort of electrical combinations are needed to be started. Okay, so this type of machine is known as simple machine. So there are 6 kinds of simple machines are there: lever, pulley, wedge, wheel and axle, inclined plane, and screw. So these 6 kind of simple machines are there, and in between these simple machines we will learn lever and pulley, because this is there in our syllabus. Okay, rest of the things are not there. Initially inclined plane is also introduced, but now it is only lever and pulley. Okay, so that's why we have to start from lever. So to tell the truth, you have learned lever many a times. I think you have learned in class 5, class 6, you have learned about lever. What is it? The lever is basically a rod, okay, or a bar which can rotate freely with respect to a fixed point, and that fixed point is known as fulcrum. Okay, here I am not going too much detailing because that one you have already learned. Okay, so depending on the position of the fulcrum, we can get 3 types of lever. Okay, so first one, number 1, that is class 1 lever, where the fulcrum is in between load and effort. This is the fulcrum, this is load, this is effort. Okay. Number 2, it is class 2 lever, where fulcrum is at one end, and here it is load, here it is effort. And class 3 lever, here also the fulcrum is at one end, in one point there is effort and the load is applied in the another point. So this is the lever, and that is the idea of lever you have already got earlier. Now we have to find out the mechanical advantage of lever. Mechanical advantage of lever, and for that case we have to take class 1 lever. We can take class 2 or class 3 also, don't have any problem. But if I calculate it from class 1 lever, that is easier for us to understand. Okay, next, mechanical advantage of lever. See, I am just going here a little faster because that things you have learned earlier. So mechanical advantage of lever. Let's see the diagram. Here there is a fulcrum, this is the load, and here it is the effort. This point we have taken A, this point is B. Okay, assume in this case if the whole thing is balanced, here you see this is the fixed point, so the effort is trying to rotate it in anti-clockwise direction, and load is trying to rotate it in clockwise direction. Okay, and in this condition, if it is in equilibrium, if the system or if the lever is in equilibrium, then as per principle of moments, we have already read principle of moments, so as per principle of moments we can write sum of clockwise moment is equals to sum of anti-clockwise moment. Okay, so what is clockwise moment here? Here you see the load is acting downward and this is the distance. Here the fulcrum is the axis of rotation. So we can write sum of clockwise moment equals to L into AF. Now that should be equals to sum of anti-clockwise moment. So here the force is E into perpendicular distance. It is BF. And from here if we find out load by effort, that is BF by AF. What is this BF? BF, you see, B is the point where the effort is applying and BF is the distance from the axis of rotation that where the effort is given. So this BF, it is taken as effort arm. This BF is taken as effort arm. AF, here in this term the load is there, so it can be taken as load arm. So BF by AF is equals to effort arm, that will be denoted as EA, that is the short form abbreviation, and load arm LA. And here load by effort, that is equals to mechanical advantage. So mechanical advantage equals to effort arm by load arm. That means by seeing the length of effort arm and load arm, we can able to understand that what will be the mechanical advantage of a lever. Coming about class 1 lever, we are coming here. Class 1 lever. So class 1 lever, the position of fulcrum can be anywhere in between load and effort. So here effort arm and load arm, sometimes effort arm will be more, sometimes load arm will be more. So for class 1 lever, mechanical advantage can be greater than 1, mechanical advantage can be equal to 1, and mechanical advantage can be less than 1 also. Okay, if I am talking about class 2 lever, so class 2 lever, you see, in one point at one terminal, fulcrum is there. Here it is load and here it is effort. You see here the effort arm means the distance between fulcrum to effort. The effort arm will always greater than the load arm. Effort arm will always greater than the load arm. So here for class 2 lever, mechanical advantage should always be greater than 1. And if I am going for a class 3 lever, here it is load, here it is effort. Here the load arm always greater than the effort arm. We have seen by the diagram. This is the load arm, this is the effort arm. Wherever the position of the effort will be, it will be less than the load arm. So for class 3 lever, mechanical advantage always less than 1. Okay, so these are the mechanical advantage of class 1, class 2 and class 3 lever. But what does it signifies? What does it signifies by seeing the mechanical advantage of the lever? Let's see one by one. Okay, one by one we have to see what is the signification of this mechanical advantage of the lever. If I'm talking about class 1 lever, if I'm talking about class 1 lever, here this one is load, this is effort, and in any point the fulcrum is there. Okay. I have already told that the position of the fulcrum can be changed to any point. Here, that's why the mechanical advantage can be greater than 1. For which case it is greater than 1? Mechanical advantage is greater than 1 for pliers. Pliers. What is plier? You know, the instrument which is mainly used to cut the wire mainly. That type of instrument. So here this is fulcrum. Okay. Here we have cutting the load. Means the wire we have cut. So this is the load. And here we are applying effort. So this is the effort. So clearly the load arm is less than the effort arm. And that's why pliers mechanical advantage is greater than 1. And it signifies that it is acting as a force multiplier, because it is not possible to cut a metal wire by hand, but using plier we can cut it very faster, because here it is used as a force multiplier. That's why by applying less amount of force we can able to create, or we can able to generate more amount of force there. But if I am talking about a scissor, I have drawn the diagram earlier also, that if I am talking about scissor, okay, in this case generally these portions are too long. So here you are applying effort. This is the fulcrum. So this is your effort arm, EA, and here you have kept a load in any position. Okay. So that is the distance of your, if I am doing the straight path, that is the distance of your load. So here clearly the load arm is greater than the effort arm. That means mechanical advantage is less than 1. And as the mechanical advantage is less than 1, here we have to give more force. We have to give more force, but will generate less amount of force. But there is a use of it. That is, this is used as speed multiplier. So that's why we can able to cut paper or clothes very faster using that scissor. So class 1 lever, for different mechanical advantage, we can use it for different purpose. If I am talking about seesaw, okay, if I am talking about seesaw, here we know that here is a fixed point and it is fixed at the middle. So here, if it is load arm, if it is effort arm, this length is same. The load arm and effort arm is same for seesaw. So here mechanical advantage will be equal to 1. And you see, if I apply load here, if I apply effort here, the load is lifting in this direction. So it is used as directional changer. Direction is changing. So the 3 purposes can be solved by class 1 lever, where when mechanical advantage is greater than 1, it is used as a force multiplier. When mechanical advantage is less than 1, it is used as a speed multiplier for case of seesaw, for case of scissor. And if mechanical advantage is equal to 1, then it is used to change the direction of application of force. Apart from this also many places it is used, that is crowbar, claw hammer, everywhere class 1 lever is used. Okay, or the principle of class 1 lever is used. Coming to class 2 lever. So class 1 lever is clear to us. Now we have to go for class 2 levers. I will not explain more, and here I am telling one thing that you have to remember, that here the examples that is not told by me. You have read the example earlier also. Now you have to go through the book. Many more examples are given. Go through the book, you will get it. Okay. Class 2 lever. So in class 2 lever, you have already told fulcrum in one point, in another point load is acting, the effort is acting at the another terminal. So here clearly you see the effort arm is longer than the load arm. Okay, so if I am talking about any such instrument like bottle opener, like paper cutter, like nut cracker, this type of instrument, nut cracker, many of you have seen, many of you not. Earlier the grandmas and grandpas, they have used this type of instruments. It is looking like this. Okay, put the substance and applying force here, means applying effort in downward direction to break it. So here it is fixed. This one is the load, so it is load arm, and this total length is the effort arm. By applying less amount of force, we can able to do or able to work or able to lift a huge amount of load there. So here mechanical advantage is greater than 1 always, and that's why class 2 lever is acting as a force multiplier all the time. Class 2 lever is acting as a force multiplier. So nut cracker, paper cutter, okay, bottle opener, everywhere this class 2 lever is used. Okay. Coming to class 3 lever. In one point fulcrum is there. Okay, here there is effort and here there is load. Okay, so here the opposite thing is occurred. The load arm is larger than the effort arm. The load arm is larger than the effort arm. So as the load arm is larger, so it is clear that mechanical advantage should always be less than 1. That means class 3 lever is always be acting as a speed multiplier. So example, if I am talking about sugar tongue, assume it's a sugar cube and this is the fulcrum. So here it is the load and we are applying effort here. Mainly in sweet shops, if you see, the sweets are taken by this type of forceps. Okay, so these all are class 3 lever. Sugar tongue, fire tongue, whenever your fishing rod, if you fishing there, your fishing rod, if you use knife, if you playing badminton, everywhere this speed, this class 3 lever is used, and where class 3 lever is acting as a speed multiplier. Okay, now we'll see very fast 2 numericals. Okay, 2 numericals from your book. Then it will be easier for your understanding that what type of questions, okay, are coming in the exam. So we will do 2 difficult numericals, and then this part, that is the first part, will be over. Okay, let's see. Coming to the numerical, we have just gone by the numericals of the book. So I am using the book, that is Selena, but you have used also concise physics, and there we are doing the exercise 3a, and where I am doing the numerical of 8. Okay, so I will do just 2 numericals, and by that only you have to understand what type of numericals are coming here in this exam, in your board exam. A lever of length 9 centimeters. So first the information is given, length of lever, that is equals to 9 centimeters. Load arm LA is equals to 5 centimeter, and effort arm, that is equals to how much? 9 centimeter. Very interesting thing. Now you see, by see the statement only, what we can able to understand. If I am talking about the 3 levers, class 1, class 2 and class 3, just see for class 2 levers and class 3 levers. Class 2 levers is like that, here the load is applied, here the effort. Okay, so this length is known as the effort arm. This length is known as the effort arm of class 2 lever. Okay, and you see, as it is a effort arm of class 2 lever, that is the length of the lever also. So for class 2 lever, effort arm should be equals to length of lever. So here you see, effort arm and length of lever is same. So what kind of lever it is? We don't know if the question is asked or not. It is clear that it is a class 2 lever. If I am talking about a class 3 lever, it is fulcrum, here it is load, here it is effort, here it is load. As I am talking about this length for class 3 lever, this is your load arm for class 3 lever, and this is the total length. So for class 3 lever, load arm is equals to length of lever. So for numerical, you have to understand that if the length of lever is equal to the effort arm, then it is a class 2 lever, and if the length of lever is equal to the load arm, then it is a class 3 lever. Then we have to ask, go for the next question. What is the question asked? First one, to which class does it belong? We have already written. It is class 2 lever. So it is first answer. Number 2, draw the diagram of the lever showing position of fulcrum, direction of both load and effort. We have already drawn it. So I am not doing it here again. So it is a class 2 lever, and this is the diagram of class 2 lever. This is effort arm and this is load arm. Our diagram is completed. Coming to the point C, what is the mechanical advantage and velocity ratio if the efficiency is 100%? Very interesting question. C portion, mechanical advantage. So mechanical advantage is what? Mechanical advantage is equals to effort arm by load arm. Effort arm is what? 9. Load arm is 5. So if I want to find it in decimal, 5 ones are point, it's coming 4 8s. So 1.8, it is the mechanical advantage. Next it is asked that you have to find the velocity ratio. But how you have to find the velocity ratio? Velocity ratio equals to displacement due to effort by displacement due to load. That you don't know. But we know one thing, that efficiency eta is equals to mechanical advantage by velocity ratio into 100, as we have to convert it in percentage. Here it is told that efficiency eta equals to 100%. It is already told here. Efficiency eta equals to 100%. So let's put the value. Eta equals to 100 is equals to mechanical advantage 1.8 by VR into 100. So 100 cancel out. VR equals to 1.8. So by that statement, we can conclude one thing. By the numerical, see what the extra thing we have learned, that if efficiency is 100%, then mechanical advantage will be equal to velocity ratio. If efficiency is 100%, then mechanical advantage will be equal to the velocity ratio. Now one question you may think that, sir, whenever the efficiency is not 100%, then which one is changing? Mechanical advantage or velocity ratio? I am telling you one thing here that you have to remember. Velocity ratio of a machine is always constant. Velocity ratio of a machine is always constant. It cannot be changed. Velocity ratio of a machine cannot be changed. But mechanical advantage of a machine can be changed. Okay, so here we have to remember that velocity ratio is always constant. So in this machine, velocity ratio is always 1.8. Maybe if the efficiency is decreased, its mechanical advantage can be changed, but velocity ratio cannot be changed. That things you have to remember. Next question, question number D. Question number D, it is asked, what will be the mechanical advantage and the velocity ratio if the efficiency become 50%? Now it is told efficiency is equals to 50%. What will happen with the mechanical advantage and velocity ratio? I have already told velocity ratio cannot be changed. So velocity ratio is equals to 1.8. Velocity ratio is equal to 1.8 always for that instrument. We have to find the mechanical advantage. We know eta equals to ma by VR into 100 if I convert it into percent, and then ma equals to eta into VR by 100, eta into VR by 100. What is the value of eta? 50. As we have already converted into percentage, we have already multiplied 100 here, so no need to write 50 by 100, so it is 50. What is the value of VR? It is 1.8. What is the value here? It is already 100, so 50 to the 100 to 1.8, so 0.09. That is the mechanical advantage. So you see, as the efficiency is changed, then mechanical advantage is changed, but velocity ratio should always be 1.8. So by this numerical only, I think you can able to understand the whole thing we have to practice here and what the things we have to remember. Just write it down, whatever the things is written here. Okay, I am just erasing this. If you are not able to write it down, just pause the video here, write down it, and then go for the next one. Now we will do the next numerical. I am going for the last numerical of the exercise. Okay, so by one numerical you see what things you have learned. Now we go for the next one, that is the last one, number 12. Okay, number 12. What it is told? It is told a fire tongue has its arms 20 centimeter long. So length of lever is equals to how much? 20 centimeter. What is it? Fire tongue. So fire tongue, we all know, fire tongue is a class 3 lever. Okay, fire tongue is a class 3 lever. So length of lever means load arm. Load arm is equals to 20 centimeter. For class 3 lever we have learned that length of lever that should be equals to load arm. Next thing it is told, it is used to lift a coal of weight 1.5 kgf. Okay, so you are lifting a weight, so it is the load. So load L equals to 1.5 kgf. It is given. Applying an effort at a distance of 15 centimeter. So effort R is equals to 15 centimeter because it is already told the effort is applied at a distance of 15 centimeter. Find the mechanical advantage and the effort needed. So very easy numerical. Mechanical advantage, if I want to find out, that is equals to load, effort arm by load arm. Effort arm is how much? 15. Load arm is 20. 5 3s are 5 4s are. So 3 by 4. So if I convert it into decimal, so 4 7s are 28 if it is taken point, and 4 5s are 20. 0.75. That is your mechanical advantage, and which is less than 1, and which is clear that for class 3 lever mechanical advantage should always be less than 1, that is 0.75. Then we'll find the effort. We know mechanical advantage is equals to load by effort also. So load is given to you, you see. You have to find the effort. Effort equals to load by mechanical advantage. So what is the value of load, you see? Value of load is 1.5. What is the value of mechanical advantage? Mechanical advantage, it is given in point, so you have to take the fraction, it is easier to calculate. So 4 into 3, so 3 by 4, I'm sorry, 3 by 4, 4 will come here. So it is 0.5, 2.0 kgf. So your effort will be 2.0 or 2 kgf, and by that you can lift a load of 1.5 kgf. So this type of numericals can be asked from the first part. My suggestion is go through all the numericals in example and do all the numericals in exercise. If you are having any doubt, then ask me. Definitely I will help you. Thank you.